This is Indira, Assistant Professor of Institute of Aeronautical Engineering, Department of Mathematics. Today we are going to learn how to find out the Fourier series in the third interval, that is minus pi to pi. Already in the last sessions we have learned how to find out the Fourier series and to which type of functions the Fourier series is applicable, and what is a Fourier series formula. And we have seen the Fourier series in the interval 0 to pi and 0 to L, and one arbitrary interval and one 0 to pi interval I have shown in the last sessions. Now today we are going to see few questions, the interval minus pi to pi, and what is the Fourier series of any function in this type of intervals. So before going to the problem of these, let us recapitulate once again the formula regarding the Fourier series. Let f of x be the function defined in the interval minus pi to pi. Let f of x plus 2 pi is equal to f of x. Then Fourier series is given by f of x is equal to a naught by 2 plus summation n raises from 1 to infinity an cos nx plus bn sin nx. Now a naught is given by 1 by pi integral minus pi to pi f of x dx, and an is 1 by pi integral minus pi to pi f of x cos nx dx, and the last one, that is a bn value, is given by 1 by pi integral minus pi to pi f of x sin nx dx. Fourier series, the problems hangs on single concept. In all the problems, there is a little bit change in the intervals, and we need to do only one thing, that is finding out the Fourier coefficients. So resubstituting in the given formula to get the infinite expansion for the given function. So here a naught, an and bn are called as a Fourier coefficients. Here a naught, an and bn are called as a Fourier coefficients. So let us see one example of f of x in the interval minus pi to pi. Obtain the Fourier expansion of f of x, which is equal to e power minus ax in the interval minus pi to pi. The Fourier series of the given function is given by f of x is equal to a naught by 2 plus summation n raises from 1 to infinity an cos nx plus bn sin nx. So let us find out the first Fourier coefficients a naught. The Fourier coefficient a naught is given by 1 by pi integral 0 to pi, minus pi to pi f of x dx. But here f of x is given as e power minus ax. So just to substitute here, so we are going to get 1 by pi integral minus pi to pi e power minus ax dx. We all know that integral of e power kx is e power kx by k. So this comes out to be e power minus ax by minus a. Minus a is a coefficient from minus pi to pi, and outside we have to multiply with 1 by pi. So here wherever x is there, you substitute upper and the lower limit. Wherever x is there, we substitute upper and the lower limit. So we are going to get it as 1 by pi, which is a product outside, into e power minus a pi, the upper limit, minus e power minus of minus plus, that is a pi, divided by a is a value which I got it. Of course, it is minus. And now we all know that this value can be written as 1 by 2, that is 2 sine h a pi, because 2 sine h a pi is nothing but e power minus theta, e power minus a theta minus e power plus a theta. So we can write this as 2 into sine h a pi. We can convert it as a trigonometrical hyperbolic function a pi divided by a pi. So this is the value of a naught, which I have got it. Now we'll put it on one side. This is the value a naught, and now we have to go to find out an value. So an is equal to 1 by pi integral minus pi to pi e power minus ax. Here f of x is e power minus ax. So actually the formula is integral of f of x into cos nx dx. So f of x, we will substitute the given function e power minus ax. So e power minus ax cos nx dx. So these are both are continuously differentiable functions. So integrating by parts is not worked out here. So we have to use the formula that is minus e power ax by a square plus b square into a cos n theta plus b sin n theta. So we have to use that formula, that is a formula by that we have brought it by reduction formula to get the integrals of the product of two continuous functions. So 1 by pi integral e power minus ax divided by a square plus n square minus a sin nx plus n sin nx from minus pi to pi. So we'll substitute the value instead of x pi and the lower limit as minus pi. So we are going to get it as 2a minus 1 whole to the power of n into sine h. Again we are converting because we will get it as e power a pi minus e power minus a pi, which can be written as 2 sine h a pi, which can be converted as hyperbolic function, divided by pi into a square plus n square. So this is what I got here, and this is a value of an value. Still one more value we need to find it out, that is bn value. So let us find out the bn value also. So bn is equal to 1 by pi integrals minus pi to pi e power minus ax sin nx dx. So we'll use the same formula because here e power x and sin nx are both are continuously differentiable functions. So we can't get the value by using the integration by parts. Again, we'll have to go for the reduction formula, that is e power minus ax by a square plus b square, a sin bx minus b sin bx. So using that formula, we are going to get it as 1 by pi e power minus ax by a square plus n square minus a sin nx minus n cos nx. So minus you take common, so we'll get it as 2n by pi minus 1 whole to the power of n. It can be converted in terms of the hyperbolic function of substituting the upper and the lower limits here, right? So which is nothing but sin h a pi by a square plus n square. So all the three values, this is nothing but the bn coefficient, that is the third Fourier coefficients. So by now we have got all the three Fourier coefficients, a naught, an and bn. So just we need to substitute in the Fourier expansion to get the Fourier series for the function e power minus ax in the interval minus pi to pi. So let us see what is the Fourier series. F of x is equal to sin h a pi by a pi, which is nothing but a naught value, we got it, plus 2a into sin h a pi by pi summation n raises from 1 to infinity minus 1 whole to the power of n by a square plus n square cos nx plus 2 by pi sin h a pi summation n raises from 1 to infinity n into minus 1 whole to the power of n by a square plus n square sin nx. Now, for x is equal to 0 and a is equal to 1, if you substitute x is equal to 0 and a is equal to 1, well, let's see what this Fourier series reduced to. So f of 0 is equal to 1, which is equal to sin h pi. That means wherever x is there, you try to substitute 0, and wherever a is there, you put it as substitute as 1. So f of 0, which is equal to 1, which is equal to sin h pi by pi plus 2 sin h pi by pi summation minus 1 whole to the power of n by n square plus 1. So therefore, 1 is equal to sin h pi by pi plus 2 sin h by pi minus 1 by 2 plus summation n raises from 2 to infinity minus 1 whole to the power of n by n square plus 1. So therefore, 1 can be written as 2 sin h pi by pi summation minus 1 whole to the power of n by n square plus 1. So this is the Fourier series for the function e power minus ax. So let us see one more example. Find the Fourier series of the function 1 plus x square in the interval minus pi to pi, and also deduce that 1 by 1 square plus 1 by 2 square plus 1 by 3 square so on is equal to pi square by 6. The given function is neither even nor odd function. The last sessions we have learned how to check whether the function is even and how to check the function is odd. Let us recapitulate. If f of minus x is equal to f of x, then the function is said to be the even function. That means if you substitute minus x in place of x, we should get back the original function. Then we call it as a even function. If f of minus x is not is equal to minus f of x, that is minus is can be taken outside with the original value, then that type of function is called as a odd function. So if it is even or odd, there is a flexibility of finding out only few Fourier coefficients instead of working out all the three. So here this function is neither even nor odd function. So we need to find out all the three coefficients a0, an, and bn. So the Fourier expansion for the given function is given by f of x is equal to a0 by 2 plus summation n rises from 1 to infinity an cos nx plus bn sin nx. Now I'm going to find out again the same the procedure, that is finding out the three Fourier coefficients. I'm substituting here. So let us find out the first Fourier coefficient, that is a0 value. So a0, how to find out the a0 value? a0 is equal to 1 by pi integral minus pi to pi f of x dx. Here f of x is 1 plus x square. Integral of 1 is x. Integral of x is x square by 2. Integral of x square is x cube by 3. So from minus pi to pi. So 1 by pi plus substituting the upper limit plus pi square by 2 plus pi cube by 3 minus of pi plus pi square by 2 minus pi cube by 3. So after cancelling the like terms and unlike terms and getting it in the least form, we will get it as the an value is 1 by pi, 2 pi plus 2 pi cube by 3. So that is 2 plus 2 pi square by 3. Similarly, I am going to find out the an value, that is the formula is 1 by pi integral minus pi to pi f of x cos nx dx. Here f of x is nothing but 1 plus x square. Okay, and g of x, and use the same formula, that is integral of f in f, which comes out to be f into g1 minus f dash into g2 plus f double dash into g3, so on. Here f is nothing but the 1 plus x square, 1 plus x square, and g is nothing but cos nx. So integrating here and substituting the limits pi to minus pi, we are going to get it as 4 minus 1 whole to the power of n by n square. So this is the second Fourier coefficient that I have got it. And let's work out the third Fourier coefficient. The third Fourier coefficient is bn. Bn is nothing but 1 by pi integral minus pi to pi f of x sin nx dx. Instead of cos, here we have sin nx dx. F of x is equal to 1 plus x square. The finding of the integral is same, but after substituting the values may differ. So here I'm getting the same integrating by parts, this integration, that is integral of f into g. And after substituting the limits, we are going to get as minus 1 whole to the power of n by n pi minus 1 minus pi square plus 1 minus pi square. So here pi square and pi square will get cancelled. We are left out with 2 pi, and plus 1 and minus 1 also will get cancelled. These two will add to get 2 pi. So minus pi and minus pi, that is minus 2 pi into minus 1 whole to the power of n by n pi. So that is nothing but 2 into minus 1 whole to the power of n plus 1 by n is the third Fourier coefficients. So I've got all the three Fourier coefficients. I'll substitute in the Fourier expansion f of x, which is equal to a0 by 2 plus summation n raises from 1 to infinity an cos nx plus bn sin nx. So I'm going to get it as 1 by 2, 2e plus 2 pi square by 3 plus summation n raises from 1 to infinity 4 into minus 1 whole to the power of n by n square cos nx plus 2 into minus 1 whole to the power of n plus 1 by n sin nx, which comes out to be 1 plus pi square by 3 plus 4 into minus cos nx by pi square, 1 square plus cos 2x by 2 square, so on, plus 2 into sin x by 1 minus sin 2x by 2 plus sin 3x by 3. So this is the infinite expansion for the function 1 plus x square in the interval minus pi to pi. So this is how we will do the expansion use of any function in the given interval by using Fourier coefficients. So here also we can estimate it. If you put x is equal to pi, the result that you are going to f of pi is equal to 1 plus pi square by 3 plus minus 4 into minus 1 by 1 square minus 1 by 2 square, so on up to plus 2 into 0, and which comes out to be the value of, because we need to do the deduction also. For deduction purpose, we are substituting x is equal to pi, assumptions that we are making to get the deduction x is equal to pi. So we'll get the deduction pi square by 6 is equal to 1 by 2 square plus 1 by 1 square plus 1 by 2 square plus 1 by 3 square, so on up till infinity. So for deduction, after getting the expansion, we can get the deduction part by assuming the x values. Okay, so either you can assume x is equal to any arbitrary value or any pi angle that you can assume for x to get the, sometimes we'll assuming 0, sometimes we have to assume it as pi to get the deduction value. So this is how we are going to find out the Fourier series of the given function in the interval minus pi to pi. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.